Today we're going to be discussing limiting reagents, and what happens in chemistry is the amount of a product is limited because one reagent or reactant runs out before the other. The way to recognize a limiting reagent problem is because you're going to see both reactant amounts given. Whereas in the previous notes, I only gave you one reactant, so then you could figure out the other reactant and figure out the product. But now if you're given both reactants, you're going to have to figure out which one will run out first. First thing you have to do, of course, is to balance the equation. So when you balance the first one, it's going to go 2, 1, 2. Now what you need to do is you need to use stoichiometry to find out if you use all 4 moles of this hydrogen, how many moles of the water would you make? So I'm going to bridge from the 4 over here, and it's going to be a little bridge. So I'm going to go 4 divided by 2 times 2, which is 4. So what I'm going to do is I'm going to write that over here, 4.0. That's like a temporary answer for now. Okay, now I'm going to bridge from this 4. And again, you could use proportions, you could use conversion factors. The bridge is clearly a quicker way, but you can use whatever way you want. So 4 divided by 1 times 2 is 8. So I'm going to write that answer over here. So let's think about what this tells us. This tells us that if I use all 4 moles of hydrogen, I can make 4 moles of water. But if I use all 4 moles of oxygen, I can make 8 moles of water. So which one's going to run out first is the one that's going to allow me to make less of the product. So this answer is the smaller answer. So that means that this one is going to run out, and this is going to have extra or excess. So what I'd like to do is I like to cross off the wrong one, and this is the right one. And so this was the first answer I wrote down, which means that it came from the hydrogen. So I'm going to use all 4 of the hydrogen. And now I have to figure out how much of the oxygen I'm going to make. So again, I'm going to use the bridge. I'm going to say 4 divided by 2 times 1, and that's 2. So I only need to use up 2 moles of the oxygen. So when I'm all done, I have none of this. I have 2 extra moles of this. I made 4 moles of that. And this is the product, the water, and then this would be called the excess reagent because I had extra, and that's the limiting reagent, the one that ran out. So hydrogen was the limiting reagent. Okay, so let's move on to the next example. We're going to do the same thing and balance it first. 1, 3, 2. So I'm going to see, does the 3 run out or the 6 run out? That's what I want to figure out. So I'm going to bridge from the 3. So little bridge again, 3 divided by 1 times 2 is 6. So I'm going to write that over here, 6.0. Then I'm going to bridge from this 6, so 6 divided by 3 times 4, which is 4. So that tells me that if I run out of the nitrogen, 3 moles, I'm going to make 6 moles of ammonia. If I run out of the 6 moles of hydrogen, I can only make 4 moles of ammonia. So therefore, this is the smaller number. That means that the second number I wrote came from this. So therefore, this is the limiting and this is the excess. So I cross off the 6 moles here because I can't make 6 moles. And I'm going to run out of all of this because that's the one that gave me the answer of 4. And now what I'm going to do is I'm going to bridge back to the nitrogen and say if I use all 6 hydrogens divided by 3 times 2, that's going to be 2. And so therefore, I only needed 2 moles of the nitrogen. So when I'm all done, I have 1 extra mole there, nothing here. I made 4 moles of this. Again, that's my product. This is the excess, and this was the limiting reagent. And that was the hydrogen. Okay, you could pause if you want and try this one on your own, and I'll do it after you unpause it. Okay, so now we're back. You should have gotten a 4, 3, 2, 6. And if you run out of all 16 of this, you would have made, let's say, if you bridged here, you would have made 24. And if you actually bridged from this 12, you would have also made 24. So they're the same answer. So it means that both of these are going to run out at the same time. You could have bridged to the nitrogen instead, and you would have gotten 8. And then you would have also gotten 8 again. So the point is that both of these ran out at the same time, and therefore they were both the limiting reagent and you made 24 of this, 8 of that, and none of the reactants are left over. Okay, the last problem is exactly the same except it's grams, so you have to be careful and use the big bridge. If you want to try it on your own, you can, or if you want to go through it with me, that's fine too. Since it's big bridge, I'm going to write down the molar masses. Remember that this is 2 grams per mole, this is 32 grams per mole, and this is 18 grams per mole. I'm going to use the big bridge to figure out the products. So I'm going to bridge from this 12. So 12 divided by 2 times 18 times 2 gives me an answer of 108. So I could make 108 grams of water if I ran out of the hydrogen. Now I'm going to bridge from this 16. So 16 divided by 1 divided by 32 times 18 times 2 gives me an answer of 18. So I can only make 18 grams of water if I run out of the 16 grams of oxygen. So this 108 is wrong. And now what I have to do is I have to figure out how much of the hydrogen I needed. So I'm going to bridge backwards from the 16 divided by 1 divided by 32 times 2 times 2. And I'm going to get an answer of 2. So I only need 2 grams of hydrogen to react completely. So when I'm all done, I have 10 grams of this left over. I have none of this. I made 18 grams of that. And so again, this is the excess. This is the limiting reagent. And this is the product. And the limiting reagent was the oxygen. Let me point out something interesting about gram problems. If you were to add up the 12 plus 16, it should be the same answer as the 10 plus the 18. Because remember, the initial is the before, and the final is the after the reaction, and the change is the during the reaction. So during the reaction, you should see that 2 and 16 react. That's going to make 18. So one more time, in a gram problem, the starting grams will always add up to the ending grams. And in the reaction itself, during the change, it's going to be the left side adds up to the right side.